right, colored pens. Last time we were together, we were introduced to the idea of an absolute value inequality, and we talked about how to solve. Let's see how we're doing so far. What do we get for this question? Start with Chris, Stephanie, Valerie, and then Edgar. Chris, what'd you get?
X is less than -21 or X is greater than 7.
Okay.
X is less than -10.5, or X is greater than 20.
Okay. Valerie?
X is greater than
Okay. Did you say 3 or 3.5?
3.
3.5. Okay.
It's greater than -10.5. I mean, it's less than -10.5.
So 3 of you said the same thing. One person was a little bit different, but in actuality, the person who was different actually had the same thing. Chris's answer was the same thing, just written as improper fractions, and that, of course, is acceptable. Now, this is the best way to write your answer. Some of you flip-flopped this expression and this expression. And I will accept that, but we did talk about the fact that this makes much more sense because the smaller number is on the left. And writing your answer like this matches the graph, because the graph will have opposite ends shaded. And if we put this the other way with the -10.5 over here, that doesn't match the graph. It doesn't mean it's wrong, it just means it's not as good as this answer. So as far as I can tell, I got 4 people who got it right, and there were a few other people who had volunteered. Give me a thumbs up if you got it right. Good, put your thumbs down. Are there any comments or questions on the warm-up? Concerns? Yes, John?
I don't understand how you got -10.5.
Okay, so that's, and I'm glad you told, because that was going to be my next question. Did you get the other part correct? If you got one part correct and one part wrong, it can mean one of 2 things. Excuse me. Sorry for the interruption. So John, it means one of 2 things. It means you either forgot to flip the sign of the answer and flip the symbol, or it means as you went through it, you made a mistake in the process. So first of all, did you flip the sign and flip flip the sign of the number and flip the symbol?
I flipped the sign wrong.
That was one problem, is you didn't flip the symbol. Okay? So I need to look at your work individually to see where you made a mistake in your process of solving. Okay? Any other comments, questions? Okay, put the warm-up to the side. We'll come back to it. Today we're going to be introduced to the idea of graphing a linear inequality. Now we've actually been doing that this entire chapter, but now we're going to be graphing inequalities in 2 variables. And this is a sequence that we've gone through already. So if everyone could turn to the back, I want to relate what we're going to see today to something you saw already. In chapter 3, here was the sequence. Equation with 1 variable, right? There was just an x. 2-step equations, but has 1 variable. So we went from there to there. Then we got multi-step and proportions. But still, it's just 1 variable. So all we did was we solved to find 1 solution. Then when we got to the end of the chapter, and the beginning of chapter 4 is when things change. Now all of a sudden, look, 2 variables, x and y. 2 variables, x and y, x and y, x and y, x and y. So it's in chapter 4 when everything changed. In chapter 4 is where we studied graphing. on a full coordinate grid and we drew lines. We graphed linear equations. But again, I want you to think of the sequence. We learned how to solve, 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 and then it changed to two variables. Well, chapter 6 actually was the same sequence, but with inequalities. Chapter 6, when we did 6.1.2.3, we did that all in one day. That was all of those first three posters right there. But it was with inequalities. Then we switched to compound inequalities. That was new, but it was still one variable. And then we learned absolute value equations and inequalities, but that was still one variable. Now today we're making the shift. Now we're going to be graphing like we did here in chapters 4 and 5. Okay? So that's, again, it's a sequence you've been through already, but now it's being done with inequalities. So, a linear inequality with two variables can be written like this. ax plus by is less than c. And it doesn't matter what symbol it is. It can be less than, greater than, or equal to. That form right there should spark a memory for you. What memory comes to mind when you see ax plus by is less than c? Maybe?
Standard form.
Very good. That is standard form. Now, standard form is something we use with equations, and these are inequalities, but it's basically the same idea. Here is a huge difference, and here was the change that happened before. When we solved, we were looking for one solution when we did equations. When we did inequalities, we solved, we found many solutions, but we graphed them on a number line. Now a solution is something different. A solution when there are two variables is an ordered pair. So now we're talking about ordered pairs that are solutions. And what that means is it's an ordered pair that makes the statement true. A graph represents all of them. That's the whole point of a graph. Here's something new. The idea of a half plane. Today, one of the major differences today is that after we graph a line, we're going to actually be doing some shading. Because what we're trying to do is represent all of the solutions to something, and inequalities have many, many, many solutions. So we're going to be doing some shading like we did on a number line, except now it's going to be in a full coordinate grid. When we do this, we're going to be shading what's called a half plane, half of the grid. Okay?
So it's one of those equations where if it's less than something, you fail the negative side.
You're going to see some examples, and you'll ask your question again later, and we'll see if we have the answer already, okay? So, this is all in words. It may not make any sense to you yet, because you haven't seen it. So don't worry about yet if things aren't clicking for you. Also, as I usually do, I like to set my students up for success, so not just relying on instinct, I also like to outline the steps for you. And so here's the steps we're going to go through. And they're all things you've always done, but now we're putting them together in a different way. To graph a linear inequality with two variables, we graph it just like if it was an equation. That's what this means. Graph the corresponding equation basically means pretend it's an equation. And one of the easiest ways to graph an equation is to put it in slope-intercept form first. Here's something new. We are not just going to draw a line. We have to actually pay attention to the style of line we're going to be using. There's two different styles. There's a dashed line, which sometimes I'll call a dotted line, or a solid line. And it's just like the open circle and the closed circle. So a dashed line is just like an open circle on the number line graph, and a solid line is just like a closed circle on the number line graph. So you have to pay attention to this detail. Unfortunately, if you put a dotted line when it was supposed to be solid, or if you put a solid line when it was supposed to be dotted, even if everything else is correct, the whole thing will be marked wrong. So you have to pay attention to this detail. So that's just drawing the line. Here's the piece that you know how to do, but you've never done quite like this. We have to figure out which side of the line to shade. We're going to shade one side. So what we're going to do is we're going to test 0, 0. If 0, 0 is a solution to the inequality, then we'll shade the side that has 0, 0 in it. If it's not a solution, then we will shade the opposite side. Now, we don't have to use 0, 0. We can actually use any ordered pair. We can use any ordered pair. But 0, 0 is by far the easiest one to plug in because you can do the mental math super fast. But if we wanted to, we can plug in 1, 1, 100, 1000. We can use any point that we want. But 0, 0 is the easiest, and so that's what we will usually do. Step 3 is a result of step 2. If the test point is a solution, as I said, we shade that half. If not, then we shade the opposite half. Today we're going to start out with a small step and then we're going to go into the whole thing. The small step we're going to start with is learning how to do this right here. We're going to learn how to do that, or at least make sure we understand what it means. And then we're going to go back and do the whole outline of steps. Now again, if you're confused already, don't worry about it. You haven't seen anything yet. I'd just like you to have the words and the language down first so that we can refer back to it if we need to. If you're missing any of this, I will give you my notes and you can fill in. So just leave a few lines if you're missing anything. So example 1, we want to learn how to test a solution. So decide if each ordered pair is a solution of this inequality. So you already know how to do this, so how do we decide if that's a solution? Okay, let's do it. Let me say it differently. Put your hands down. Give me a thumbs up if you think you know how to figure out if it's a solution. Okay, so some of us think we know. Good. Alexandra, what do you think we do? Good. Plug them in where? Very good. So we take these coordinates and plug them into the right letter, and then we just simplify. But we have to actually be careful of what we're looking for. But let's go ahead and do that step first. So it's going to be 8 times x minus 4 times y, and we're going to ask ourselves, is that greater than or equal to 3? And so we're using 0, 0, and so we're going to put a 0 there and a 0 there. So now simplify. 8 times 0 is 0. 4 times 0 is 0. And so, of course, this is 0 is greater than or equal to 3. Now we have to decide if that is a true statement. So we are looking at this statement right here. It's either true or false. Give me a thumbs up if you think that's true. Okay, good. So nobody put the thumbs up, which means that everyone thinks it's false. And it is false. That's a false statement. And what that means is 0, 0 is not a solution. If you get a false statement, not a solution. If you get a true statement, it is a solution. That's what solutions are. So here we're going to say no, or you could say not a solution. And this proves it. Any questions on how we did that? Dalton?
Can you just put false, or should we put?
If you write false, I guess I understand what you mean, but saying is that a true is 0, 0 a solution, and you say false. It's just a weird way of saying it, so you say yes or no, but I understand what you mean. Try not to stress too much about it. So part B, let's see if that is a solution. So we've got the same inequality, 8 times, but this time we're going to plug in 1, negative 1. So we have 8 times 1 is 8, minus a negative 4 times a negative 1 is a positive 4. So that's actually plus 4. 8 plus 4 is 12, so we get the statement 12 is greater than or equal to 3. Give me a thumbs up if you think that is a true statement. A lot of people think it's true. Good, because it is. It is a true statement. So the answer is yes, that is a solution to the inequality. Does anyone have any comments or questions on how we did this? John?
So if there's a possibility to where we're supposed to choose our own points, say if I were to choose one that's red and another one would it still count?
What do you mean? I'm not sure what you're asking. You don't have to do anything. We're doing 2 because I wanted to do 2 different ones. This has nothing to do, all we're trying to learn how to do is how to decide if something is a solution or not. We could have done 10 of these. We could have done 15. And we could actually go on and on and on for a very long time. I think 2 is enough to get the point across. Okay? All right. So now we're going to take that skill and apply it to the entire process. So, we want a graph 2x plus 3y is less than 6. You have 3 different methods for graphing. They're actually still up there. You learned how to graph using a table of values, graph using intercepts, or graph using slope-intercept form. Today, I'm going to choose for us. When you have your own classwork and homework assignment, you can choose which method works for you. But for now, we're going to use slope-intercept form, which means that I would like to rewrite this with the assistance of my students. I would like to rewrite this into slope-intercept form. You should already know what that means. In fact, it should seem unbelievably easy to you at this point. So, what's the first step in getting this into slope-intercept form? Start with Fung and then Extol. Fung, what's the first thing we're going to do? Good. Subtract 2x from both sides. So we'll subtract 2x. This will disappear, and I'm left with 3y is less than, and notice I'm putting the negative 2x first, that's something you learned a long time ago, plus 6. Did I multiply or divide by a negative number? That rule still applies, so you have to remember that. That's one of those little details that if you don't pay attention to, you will get a lot of things wrong. So, we are at 3y is less than negative 2x plus 6. What's the next step, Extol?
Divide everything by 3.
You said that beautifully. Divide everything by 3. This will cancel, and I'm left with y is less than. That's already in simplest form. Negative 2/3 x plus 2. So now we have the inequality in slope-intercept form. Does anyone have any questions on how we did that? Now we have to graph it. So we're not even done with step number 1, but I went a little bit slowly. When you do these on your own, you should be able to get through that part pretty quickly. So now we need to graph. So everyone take 10 seconds to draw a grid. I passed around rulers for those who need. So a lot of you have your own. So, we, again, should feel extremely comfortable. I'd say borderline expert at graphing with slope-intercept form. What's the first thing I should do? Just 6 people can tell me the first thing? Okay. Matthew? Yeah, what's that called? The y-intercept. Yeah, this is the y-intercept right here. You go up to 2 on the y-axis and you put a point. That's the y-intercept. Got a comment or the next part? Okay, I'll get you one in a moment. So how do I go? That's not a line, so I need to do something with it. What's the next thing I need to do? Caleb? It was a little hard to hear you. I heard down something. Very good. You said that beautifully. So, you can either move the negative sign up or you can move it down. Either way, you're going to get the same result. So if we move it up, that means we go down 2 over 3 and put another dot. Or I can move it down and I can go up 2 to the left 3 and I can put a dot. But either way, I'm going to get the same line. Don't draw your line through it yet. If you did, you made a mistake. So we do need to draw a line through it. But now we're more advanced and it's an inequality. There are 2 different styles of line. Which style of line are we going to use for this graph? Are we going to use a dotted line or a solid line? Shannon? Are you sure? What did you think, Sebastian? Dotted or dashed? Why? Yeah, the symbol doesn't have the or equal to, so that means we use a dashed or dotted line. So you're going to use your ruler, and it's actually not hard. If you put the ruler down, put the pencil along it, and then push the pencil down, draw a little bit, pick it up, and then put it down. You can actually do it quickly, just kind of going like this as you go down the line, and it will draw a dotted line for you. I'm lucky I have the power of the computer to help me, and so I can draw So we have hopefully successfully drawn a dashed line to represent the graph. I'm sorry, to represent the inequality. Does anyone have any questions on how we got from here to here? Comments or questions? John? Yes, we do. We still use arrows because, remember, we're trying to represent all the possible solutions, and this line will go on and on forever in either direction. But now we need to shade half of this. We either need to shade up here, or we need to shade down here. And here's where steps 2 and 3 take over. We have to decide which way to shade. So the way we do that is we're going to test this point right here. We're going to test that point right there. If that point is a solution, then that means that all of these are solutions and that we need to shade this whole area. If it's not a solution, that means that all the solutions are up here and we need to shade up here. So now we're going to do the test. Here's the test. We plug 0, 0 into here, or if you wanted to, you could plug it into the original inequality up here. Either way, you will figure out the correct answer. But I'm just going to plug it in here because I have it. So 0 less than negative 2/3 times 0 plus 2. So I simplify and I get the statement 0 is less than 2. Is that a true statement or a false statement? Give me a thumbs up if it's true. Good. Most of us think it's true. It is true. This is a true statement. Which means that this point is one of the solutions. And because I've proven that that's a solution, then we can say that the rest of these are solutions as well. Now again, I am lucky I have the power of the computer to help me along. You're going to use your pencil like an artist would and use the edge of the pencil to do broad shading strokes, and that will make it easy. But I'm going to do this, and I'm going to shade this whole area down here. And you don't have to go beyond your grid, but whatever size your grid is, you need to fill in that whole area right there. So now we have successfully graphed a linear inequality in 2 variables. So the green graph is all of the solutions to this inequality. So I want to talk about that for a moment. Could I have some volunteers pick a point for me in the shaded region? Pick any point in the shaded region that's on our grid. Just pick it. I got 6 people who can do that? 7 people? 8 people? Okay. -1, -1. So everyone just watch. -1, -1. So that point right there. What should happen if I plug those coordinates into the inequality? What should happen? Can you hear? It should. It should make a true statement. And in fact, if I plug those coordinates into the original up here, it should be a true statement as well. Can I have another one? Pick another point in the shaded region. Fun? -5, -5. -1, 2, 3, 4, 5. -1, 2, 3, 4, 5. So negative 5, negative 5. What should happen if I plug negative 5 comma negative 5 into the inequality? What should happen? Edgar? Should make a true statement. Good. Could I have a volunteer pick a point in the unshaded region? In the unshaded region. Dave?
0, 4.
0, 4.
4, 0.
Well, let's go with 0, 4 first. 0, 4. 1, 2, 3, 4. Right there, and then you quickly changed it and you said 4, 0, which is right here. But they're both in the unshaded region. What should happen if I plug those coordinates into the inequality? What should happen? 4, 5, 6, 7, 8. Caleb? Statement should what? It shouldn't be true. It should become a false statement. And that's correct. Any point in this region here, anything, anywhere over here, will make this false. Anything here will make it true. Does anyone have any questions about that? Comments or concerns? Good. We're doing pretty well so far, but let's see how you do on your own. Checkpoint number 1. Please keep in mind that everything you have done in my class applies to this question. Every tiny little detail, everything that you were taught applies. So make sure you watch your details and double check your work. up your colored pens. And this is not a volunteer and share type of question, so I'm going to reveal the graph and you're going to check your own work. Many of you are going to be proud of yourselves, but some of you are going to be disappointed because this was actually a challenging question, but we'll talk about that in a moment. So here is the graph. And it's a little bit hard to tell because the software I used to make it didn't draw the nicest line, but this is a solid line going from here to here. So of course, first mark yours correct or incorrect, and then we need to talk about either what was right and what was wrong. So, first of all, let's just look at the line itself. Give me a thumbs up if you have the same line that I have. Okay, put your thumbs down. So that was a decent portion of you, but definitely not enough. But we'll talk about that in a moment. Give me a thumbs up if you have this line, but you have this side shaded. Good, put your thumbs down. Okay, so that's actually fewer people than I thought would make that mistake. Okay, so there was a few of you. If you have this exact same line, but you shaded this side, it's because of one detail that you missed. So let's talk about how to convert this. So let's go from here to slope-intercept form. What's the first step in getting it in slope-intercept form? Hey, so what was the first step you did? Very good. Subtract 5x from both sides. But what is this right here? That's a subtraction symbol that does not disappear when you subtract 5x from both sides. So here's what you end up with. Negative y is less than or equal to negative 5x plus 3. That subtraction symbol does not disappear. You have to do something to get rid of it. What do we have to do to get rid of it? Enya? You have two choices. You can either divide both sides by -1, or you can multiply both sides by -1. Either way, it doesn't matter. You're going to get the same result. That's going to flip, and that's going to flip. But something else happens. What else happens when you do that? Go ahead, Danielle, you're on a roll. That's right, she said that beautifully. There's that rule that I've taught you that's supposed to be on a banner or hanging in the back of your head. If you ever multiply or divide by a negative number, you flip the symbol. So you were supposed to flip this symbol and it becomes y is greater than or equal to 5x plus 3. I'm sorry, minus 3, my mistake. Minus 3. So now you go down to -3, you put a dot, and then you rise 5 over 1. You get your next dot right there. Draw a solid line. Now you have to test 0, 0. And so you put a 0 here. And you get 0 is greater than or equal to -3, which is a true statement. And since it's a true statement, that means that is a solution right there. Which means that half should have been shaded. If you did not flip the symbol, then you would end up with a false statement and you would have thought you were supposed to shade the other side. Comments or questions on how we did this? John?
I made a mistake. My line is that, but it's just not.
Okay. Okay, well, but do you see this here? Okay. So the problem is that some of you saw this and you just said, oh, well, I don't need to do anything about that, and then you graph that. But you're not allowed to do that. You cannot graph, this is not slope-intercept form until this is a positive 1. So that's one reason why people had graph going in their line going in the opposite direction. Comments, questions? Kayla?
Okay. I forgot about the negative y part, so I didn't write the negative sign, but I tried out the 0, 0 thing, and it still worked, so I still got it right.
But your line must be wrong. Well, if you just got that, but you ignored the, then your y-intercept was 3. You had a positive 3 instead of a negative 3. I'll come look at yours individually. All right, so now, what will happen if we need to graph an inequality that looks like this? Well, you already know how to do it, for the most part. You were taught how to graph x equals 3. Unfortunately, some of you didn't digest it at the time it was taught a long time ago. And so now's your opportunity to revisit it and try and get better. And if you continue to not pay attention to this type of question, you're going to give yourself you're going to make it so that you're missing out on questions that are supposed to be gifts. This is a super simple graph to make. X equals 3 means to go on the x-axis to the number 3, right here, and you put a dot. And then you are to draw a vertical line through it. It's easy to forget which one's which and which way it's supposed to go. But that's part of your job, is to remember which way it's supposed to go. So we're now going to draw a vertical line through that point. And that is the graph of x equals 3. But we're not really trying to graph x equals 3. We're trying to graph x is less than 3. I'm sorry, x is greater than 3. So now we need to do a test to see which way we're supposed to shade. We're going to test 0, 0. Yes, Umar. It's supposed to be a dotted line, so I already made a mistake. But that's easy to fix because if you have an eraser available, you can just erase bits of your line and it will turn into a dashed line. Thank you for pointing that out. So I apologize for that mistake, but it happens. But now I need to decide which way am I going to shade. Am I going to shade this side or am I going to shade this side? So I need to test out 0, 0. But I don't know where I'm supposed to put 0, 0 because here's my inequality. So what am I supposed to do here? This is an x and that's a y. I only have an x. I have no idea what to do. Any thoughts? You have a few thoughts? Sebastian? Yeah, he's right. We just put in the x. So x is 0, so then we just put this. And now we ask ourselves, is that a true statement or a false statement? Give me a thumbs up if you think that's true. Thumbs up if you think it's true. Okay, nobody thinks it's true. That's good, because it's false. Since it's false, that means this is not a solution. And since that's not a solution, I should be shading the other way. And so we are going to shade over here. Any comments or questions on how we did that? Good. So, what if it was a y? Well, it's the same basic idea. Excuse me, sorry. So, you were taught how to graph y equals -4. Where do I go and what do I do? Dalton?
You graph the horizontal.
Yeah.
You go down -4 on the y.
That's right. I'm going to put a -4 right there. Now let's make sure I don't make the same mistake again. It's going to be a solid line. Okay, so this time I can do this. But now I need to figure out where to shade, and I have the same issue I had a moment ago. I need to test 0, 0. However, I've got this inequality. And so we follow the same thing that Sebastian said, is that we just use the y. So 0 is less than or equal to -4. Is that a true statement or a false statement? Give me a thumbs up if you think that's true. Nobody thinks it's true? Good, because it's false. Which means that 0, 0 is not a solution, and so we need to shade the other direction. So we're going to shade all down here. Does anyone have any questions, about how we graph either of these? Now, there is a shortcut to figuring out which way to shade. I am not teaching my students the shortcut, but I do expect many of my students to discover the shortcut. So I've heard many of my students shading even before I started teaching what to do. So you either figured out a shortcut already, and it seems like it works, or you were just way ahead of us. But for all of these, there's a shortcut to figuring out which way to shade. It's your job, if you so desire, to figure it out. It will help you save a lot of time if you can figure out the shortcut. Now, any questions on graphing or shading these? Good. We have one last goal for the day, and that is to be able to go in reverse. So what we've done is we've taken inequalities. And we've graphed them. So we've done 4 already. 4 of them. But now, and you do not need to draw this graph, you just need to look at it. Now, we need to write an inequality from the graph. And this is what we learned in chapter 5. The entire chapter was how do you write an equation when you are given different pieces of information. When we're given a graph, that was the easiest situation for us to write an equation from. So we want to write y equals mx plus b, and then we'll deal with this symbol at the end. Can anyone pick out any of these pieces of information right off the bat? Alexander? Very good. The y-intercept is right here. It's right there on the graph. It's 2. So I already know that that's going to be a 2. What else can we pick out? Danielle? Which is? -1/3. Let's see. Here's a point over here. So we go -1/3. So it's -1/3. And so here we have most of what we need. But we need to know what symbol is going to go right there. And this is the hard part. Here's where we use the concept of 0, 0 to help us, but we do it in reverse. Here's 0, 0, right here. Is 0, 0 a solution or is it not a solution? It's not a solution. So I want to plug it in here. And then I want to figure out which symbol would have to go in place to make it a false statement. Right? If I take 0, 0 and I plug it in here, I want to figure out what symbol would go right there to make it a false statement. So let's simplify this first to get the numbers down. So this is going to be a 0, and then this will just disappear, and so we've got 2. So I can put this symbol, or I can put that symbol. Which one will make this a false statement? Which one will make it a false statement? Chris? Greater than, and we'll talk about the or equal to in a moment. The greater than symbol will make it a false statement, and that's what we wanted, so we know that that's going to be a greater than. But then you also said or equal to. How did you know it was going to be or equal to? Very good. The line is solid, which means that it's going to be or equal to. So, this is the inequality for this graph. Does anyone have any questions on how we did that? It was not easy. All right, so now you're going to get some independent practice. Draw a line across your paper. Your classwork is on page 71. You're going to do 25, 24, 20, 17, 13, 12, 8, and 4. Of course, I will be circulating to assist. All right. So let's see how we're doing so far. Gave you a few challenging ones to begin with. Number 25. There was really 3 parts, even though it was part A and B. You had to write an inequality, and you had to graph the inequality. Luckily, the grid was already provided for you. You just had to fill it in. And then 3 possible combinations. We've been talking about the concept of combinations throughout the year. And so as long as you picked any point inside this region or on this line, then that will count as a combination. For example, 1 pair of pants and 4 shirts is a combination. 2 pairs of pants and 1 shirt is a combination. 3 pairs of pants and 2 shirts is a combination. 1 pair of pants and 3 shirts is a combination. Any point within this region is a combination, which is also a solution to the inequality. So that was number 25. 24, you had to write the inequality. 20, To graph the inequality, that should have taken you a nanosecond. I'll go back to 25 again if you need me to. Here were these three, and I don't think we got past this. Let's see, what did we have? 17, 13. So I'm sorry, so that got cut off. That's number 17, 13, 12. Was anyone able to get to 8 and 4? I didn't expect you to. Okay, good. Does anyone need number 25 back up? Okay, so you got some good independent practice time. Are there any general questions that I could answer about these? Yes, and then yes. 24, and what was yours on? Number 25, okay, start with number 24, go ahead. The slope, the slope,
No, why?
okay. We're trying to write an inequality that represents this, and we're starting with y equals mx plus.
Bless you.
Thank you. So we need the b, which we couldn't see. So that was an additional challenge when we don't know what the b is. What do you do to find the b if you can't see it? You were taught how to do this. Kadir? Okay, so you want to just continue the line until you see it. Okay, that's good. Funk? That's right. You could use this, and if you know the slope is -2, you can use an ordered pair. You can use an ordered pair, plug it in, and simplify and solve, and you would get -5. That's what you were actually taught to do way back in chapter 4 and 5. Okay? So, Kayla, you had a quick question about number 25? I'm sorry? Yeah. What would be a great method to use for graphing, even though I insisted on using slope-intercept form? What's another great method for graphing when an equation or an inequality is like this? Stephanie? Yeah, if you use intercepts. If you can find this point and that point right there and then just connect the dots, you save yourself a lot of time. Now, we didn't do that during the lesson, but I did say that I was insisting on using slope-intercept form, but when it was your turn, you could choose any method you would want. Okay? So on your homework, use whichever method makes the most sense to you. Okay, I do have to hustle up and give you your homework. So draw a line across your paper. Your homework is page 417, numbers 14 through 44 even, and numbers 52 and 54. Then you have a few review questions. Page 902. Make sure you write the correct page number. Page 902. Numbers 13 through 16, and that is 13 through 16 all. And then on page 905, you're going to do 53, 54, and 55. That's 53 through 55 all. And then on my whiteboard over here, I have